Alright, so today you guys will be watching a video about creating a function rule. I may be stopping in at any point, so we should all be paying attention to this video. Right now, you will have about, 5 minutes to do these 3 questions for the warm-up. So I will put a timer for 5 minutes and you will stop the video and then wait 5 minutes and then go from there. So pause the video now, put 5 minutes, answer these 3 questions. It should only take you honestly 2-3 minutes. I will be checking these. Make sure that you have today's title, which is creating a function rule. Alright, so pause the video now. Okay. Alright, so the first problem we're going to be talking about is to write a function rule. So you do not need to write the problem down, but let's get into this. So problem 1 is to write a function rule. It says that insects, you can estimate the temperature by counting the number of chirps of the snowy tree cricket. The outdoor temperature is about 40 degrees Fahrenheit more than 1/4 the number of chirps the cricket makes in 1 minute. What is a function rule that represents this situation? Alright, so first thing we got to do is we got to dissect this. So we need to take what we know of this problem. Okay, so that know part is this part right here. Okay, the outdoor temperature is about 40 degrees Fahrenheit more than 1/4 the number of chirps the cricket makes. Okay, and the cricket makes in 1 minute. So what we know the temperature, and everybody should be writing this down. The temperature is what? Is 40 degrees Fahrenheit more than 1/4 the number of chirps in 1 minute. So that's everything we know. Alright? From this problem, the temperature is 40 degrees Fahrenheit more than 1/4 the number of chirps in 1 minute. Okay? Everybody should be paying attention. Alright? Now we need to provide some variables. So our V. Alright? So our V's stand for variables. Okay? So we need to know what the temperature is. So T for temperature. T equals temperature. And the other thing we need to know is the number of chirps. So we'll say N for number of chirps. Alright? And now let's write this out. So my temperature is 40 degrees more than 1/4 the number of chirps. So we don't know my temperature yet. So we have to put T equals 40, because 40 is what it is. Temperature is 40 more. So if it's more, that means it's got to be plus 1/4 the number of chirps. Well, we don't know the numbers, so I have to do 1/4 times N. Okay. Another way I could write this is T equals 40 plus 1/4 N. Okay. Remember that if a number and a variable are right next to each other, that means that it's multiplying. Fourth period, we should know that because we talked about it multiple times. When a number and a variable is next to each other, It is multiplying. Okay, so all we did was we dissected this word problem. Okay, so we started with the word problem, we defined what we know, we made some variables, and then we went ahead and created the problem. All right, let's move on to the next one, number 2. Number 2 is writing and evaluating a function rule. So you should be writing this down. Do not have to write the problem, so don't worry about the problem. Okay. All right, so the problem says a concert seating plan is shown below. Reserved seating is sold out. So reserved seating is this red right here, and it is sold out. Total revenue from ticket sales will depend on the number of general seating tickets sold. Okay, write a function rule to represent this situation. What is the maximum possible total revenue? So what do we know? Okay, so we know that total revenue that's this part right here. Total revenue is general seating, because that's what it says, general seating. So total revenue is dependent on general seating, and so would it just depend on this whole section right here? No. What else would it depend on? Plus reserved. Plus reserved seating. Okay, so my total revenue is both areas, this and this area together. Okay, so when you go out and if you're ever a performer, if you sell out, that means all of those seats are coming into your revenue. Okay. All right. So what do we need to know about general seating though? So in general seating, is there anything we need to know? Well, yeah, we need to know how many seats and how many rows we have. So price, and we need to know the price. So the price per ticket, right? We need to know this, the $10. And we need to multiply that by the number of tickets. Number of tickets. All right, now we already know our reserved seating, so we know that this is already sold out. So this red area is already sold out. This yellow area is not sold out. Okay, and that depends on how many tickets we sell and how much those tickets are worth. All right, so now our variables. Okay, so we need to know my total revenue. So we need to know R for revenue. And we also need to know how many tickets, because we know the price of these, we just don't know the ticket numbers. So we'll say T for ticket. All right, and those are the only two variables we need. We know how much my reserves are. We know how much the price is. We just don't know the number of tickets. Okay, so now let's create our problem. So let's write it out. Our total revenue, do we know that yet? No, my revenue is R. My R equals general seating. Well, do I know the price of that? Yeah, the price is $10. It says it up here. The price is $10. Okay. Do I know the number of tickets sold? No, so I have to multiply 10 and N. So 10N, and then this word plus is right here. Notice that I'm just following along my no. So total revenue equals price, which is 10, times n plus my reserved. So how much is a reserved seat? A reserved seat is $25. Okay, and I need to multiply that by 10 and 12. Well, where did I get 10 and 12 from? 10 is the rows, 12 are the seats. So in each row, there are 12 seats, and there is a total of 10 rows. So if I multiply all these together, and I simplify this, my total comes R equals 10n plus 3,000. 25 times 10 times 12 gives us 3,000. Okay? So again, all this is total revenue equals general seating plus reserved seating. General seating is $10, reserved is $25. There's 10 rows times the 12 seats. Okay? All right. Let us move on to our last question. Question number 3. Question 3 says, writing a non-linear function rule. So a non-linear function is just a line that is not straight. So these are lines that are not straight. Usually have us involving multiplication. All right. So it says write a function rule for the area of a rectangle whose length is 5 feet more than its width. What is the area of the rectangle when its width is 9 feet? So one more time, we should all be paying attention. This is our last question, and let's get into this. So our step 1 is let's just visually represent this. So I have a rectangle. Okay, and we should all be writing this down. And it has a width and it has a length. The area is the inside, so it's all of this. This is my area. Okay, area is equal to length times width. So that's just how we visually represent this. Now it says, step 2, let's recreate what it's asking. So let's recreate a rectangle. My area is in the middle. My width is here, but the problem says write a function rule for the area of a rectangle whose length is 5 feet more than its width. So my length, instead of L being here, it's going to be W plus what? How much more is it going to be? Well, it says it's going to be 5 more. So my width plus 5. So now, step 3 is to write this out. So using the diagram in step 2, let's write this function rule. So my area equals my width times my W plus 5. Because remember, instead of L, it's going to be W plus 5. Okay? Now, what is the area of the rectangle when its width is 9 feet? So my width equals 9. So let's rewrite this. A equals, what's my new W? So right here, my new W is 9. So it's 9, in parentheses, 9 plus 5. And now let's solve this. PEMDAS tells us to use parentheses first. So 9 plus 5 needs to go first. And 9 plus 5 gives us 14. So what do I do with this 14? I put it back in parentheses and I put 9 on the outside. When I see a 9 and a 14 on the inside of parentheses, that means I need to multiply. So if I multiply these two together, it's 126. So this area is 126. Alright, so that is it. I will stop by, probably not in first period, but fourth period I definitely will. So that means we need to be working hard, and fourth period, you did not do well last time. Just telling you. So be ready for a quiz. Alright, so I will leave this here. If you need to rewatch the video, please do so, and I will see you guys later.